Okay, super. And
Sure.
screen is yours.
So thank you. My name is Piotr Żerdziński. I am student of Żerdziński University of Technology, and I would love to tell you about the paper I prepared for today. So the topic of this presentation is fine-grained visual classification of fish images. To better understand the subject matter, it is important to explain what fine-grained visual classification is. So it's the specific example of visual classification, of course, in which the classified images belong to one larger metaclass. An example could be the classification of car or airplane brands, but more relevant are attempts to classify species belonging to higher taxonomic levels, such as dog breed or fish species. Of course, this is not the rigid division, because in the case of classification of aquatic species, a dolphin, which is a mammal, or shrimp, which do not even belong to the same taxonomic phylum, can just as well be classified. Therefore, fine-grained visual classification is a more demanding problem due to the need to distinguish often small differences between the analyzed classes. Thus, sticking to the presented case, to distinguish between two fish species, it is necessary to rely on features such as fin shape or differences in coloration. Mm, so, among all vertebrates on Earth, fish exhibit the greatest biodiversity, with more than 30,000 species and more being discovered each year. It is therefore necessary to monitor biodiversity to maintain health ecosystems. However, manually examining hundreds of hours of recording by specialists is too costly and time-consuming. In this context, automated image classification system become invaluable, as they allow continuous classification at the fraction of the cost and time required by the traditional methods. The primary objective of this work was to create a model capable of effectively classifying underwater fish images. And this model must be able to cope with challenging images while not being overly complex. My ultimate goal was to develop the lightest possible model that could serve as a foundation for dedicated solutions. Each environment is characterized by a specific condition: lighting, camera quality, or water quality. And therefore, a specialized image preprocessing procedure should be implemented for each case to extract the most essential elements. Also, for this dataset, a very simple image transformation process was proposed, which significantly improved prediction accuracy, thus minimizing the model while maintaining the highest possible performance was the most important objective of the presented work. The dataset used in this work is called the Croatian fish dataset. It consists of only 794 images of 12 fish species found in the Adriatic Sea in Croatia. Originally, the dataset contains recording with full HD resolution. However, once the fish were located, they were cropped from the initial recordings. The way this dataset was created is the source of its biggest problem. The original recording are not in the perfect resolution, resulting in some images being very small, only 90 by 23 pixels. This means that the photographed fish are just spot of the slightly different color than the background. Another problem is the lack of balance between class sizes. The smallest class is having only 70 images, while the others have at least 50. The dataset concentrates all the potential problems one might encounter while attempting to classify this type of images. We have a small dataset with imbalanced class distribution. The images are of poor quality and often very small and lacking any details. Additionally, there are issues related to the nature of the underwater photography. Working on images taken underwater, we are forced to solve problems caused by the quality of the analyzed images: noise, discoloration, and distortions. Water and particles dispersed in water, like pollution, plankton, etc., absorb, scatter, and reflect sunlight. the extreme wavelengths in the visible light range are particularly strongly absorbed, and the dominant color of the images are therefore green or blue. And for this reason, any differences due to the color of the fish are lost and almost invisible. So, as I mentioned in the introduction, fine-grained visual classification of any dataset must address the same challenge, capturing the small differences that make one class distinct from the another. For this reason, I propose the attention-based CNN model. Attention mechanism widely used in similar works allow the model to focus only on the significant element of the images, ignoring those parts that do not carry essential information. Thus, in our case, the model ignores the background in favor of specific fish features. Additionally, a mechanism of skip connections was utilized, which allows the network to preserve low-level features while also combining them with the higher-level abstractions. This can lead to richer and more informative representation, improving the overall performance of the network. Skip connections was added to the presented architecture inspired by DenseNet, but only for the first layer, as it's the only one connected to each subsequent layers. Originally, the DenseNet had outgoing connection from each layer. In principle, this model is intended to serve as a base for dedicated solution tailored to specific applications. Therefore, for the analyzed dataset, a simple image preprocessing, as I said, was prepared, and each image was simply brightened. This way, for the blurry images, the brightening allows the fish to be significantly separated from the background, while for the more accurate ones, the fish's features become more visible. Classification of the Croatian fish dataset using the presented architecture was carried out into two stages. Results were compared both for data not preprocessed and after applying this simple transformation. So in the first case, an accuracy of 91.41% was achieved, while after applying preprocessing, the results increased to 96.88%, which is the highest achieved results among published works. So on this slide, you can see the graphs of the results obtained on the analyzed dataset. In blue are the results obtained after preprocessing, and in orange are the results of the sample without any preprocessing. The first two graphs shows accuracy and loss function for the training set, respectively. As expected, the graph for the preprocessed data converges to 100% faster and more stably. And a similar pattern is observed for the results obtained for the test set, for the accuracy, precision, recall, and F1 score. And the only noticeable difference is the drastic drop of stability. For the preprocessed data, the fluctuation in results are smaller, but still noticeable, which is obviously due to the small size of the entire data set and consequently the small size of the test set. So the presented paper introduced the attention-based CNN model with skip connections and dedicated preprocessing. The architecture tested on the Croatian fish dataset achieved the highest accuracy among published works to date. An important advantage of this paper is the fact that the proposed model is lightweight compared to the large pre-trained CNN models. In future research, it would be worthwhile to focus on further developing universal image preprocessing that could address the main issues associated with this type of images. Possibly direction for the further work include the use of generative models to enlarge images with improved quality. Additionally, more advanced methods to recovering true colors could be explored. So, thank you for your attention. That's all for us. I prepared for today.
Thank you very much for your presentation. It was interesting to listen, and you are our final presenter in this section. So thank you all the presenters of this section. Basically,